All right, we are on lesson 2.2. So to start off, we just have some warm-ups. For in class, we're going to vote with our fingers. For you, I just want you to pick claim number 1 or claim 2 if you're just watching the video. So we have 2 claims for the next few lessons. Claim 1 says, molecules speed up when energy is created and slow down when energy is destroyed. Claim 2 says molecules speed up when they get energy from other molecules, and they slow down when they give energy to other molecules. So think about which one of these 2 claims do you think is true? You don't have to write anything down right now, just think. Okay, next we have 2 samples, A and B. Which one of these 2 do you think is hotter? Think about it for a moment. All right, this is from the sim, and if they are glowing yellow, that means they have more kinetic energy. If they have more kinetic energy, that means they're moving around more and more, which means they should be hotter. So sample A should be hotter. Okay, here, which is hotter, C or D? The important thing to notice here are the movement lines. So D has longer movement lines. That means these molecules are moving faster on average. If they're moving faster, this one has more kinetic energy and is probably going to be hotter. All right, which of these is hotter, E or F? So this one's a little harder to just tell intuitively. So we need to calculate the average kinetic energy for these. To calculate the average, you add all the numbers up and you divide by however many numbers are in your sample. So both samples have 9 numbers, 9 little dots. So let's figure out what the average of E is and the average of F. So we're going to add these all together. 4 plus 5 is 9, plus 3 is 12, plus another 4 is 16, plus 5 more is 21, plus 3 is going to be 24, plus another 3 is 27, plus 4 is 31, plus 5 is 36. So sample E has a total of 36. We divide by the number of circles in the sample. 36 divided by 9 is 4. So the average kinetic energy of E is 4. Now let's do F. We're going to add them all together. 3 plus 4 is 7, plus 2 is 9, plus 3 is 12, plus another 2 is 14, plus 4 is 18, plus 4 is 22, plus 3 is 25, and plus 2 is 27. So sample F is a total of 27. There are 9 molecules, so 27 divided by 9 is 3. So which one of these 2 is hotter? That should be sample E. This is question 50 that we are doing right now. So sample E is the hotter one because it has an average of 4. Sample F is the cooler one. It has an average of 3. All right, remember, we are investigating this question. Why do molecules change speed? Over the next 2 lessons, you're going to evaluate and choose between those 2 claims that we started our warm-up with. One says that molecules change speed when energy is destroyed or created. The other one says that the molecules give up or gain their energy to other molecules. So let's look at some evidence. Let's do some reading. Our reading today is going to be how air conditioners make cities hotter. So first of all, you are going to preview an article and summarize the title, the picture, and the captions. Then you're going to do summaries for paragraphs 1 and 2, 3 and 4, 5 and 6, 7 and 8, and then you will summarize the article as a whole. So let's open up the article here in question 51 in your notes, and we're just going to look at it. I'll help you with the previewing summary and then leave you to do the summary of the article or the paragraphs together. So the title is How Air Conditioners Make Cities Hotter. And it shows a bunch of AC units on top of a roof. And it says the air conditioning system sits on a roof of a building. It transfers energy out of the building's air to keep the building from getting too hot. Let's scroll down. We see someone that looks like they might have a fever. They've got a thermometer and they're putting something on their forehead. This says when you have a fever, placing a cool, damp washcloth on your forehead can help cool you down. Here it shows another picture, same thing. We have hot forehead, cold washcloth, and it looks like energy is going from one location to another, and there's a little key showing the amount of energy. So, what am I going to summarize for the title and the picture? All the pictures seem to show heat being taken from one area and put into another. In this case, it's out of the building into the atmosphere. Here it's from the forehead into the cool washcloth. Same thing here, from the forehead into the cold washcloth. So, preview the title, pictures, and captions, summarize what you see. I'd say we see energy being transferred out of one place and into another. So next, you're going to do two paragraphs 3 and 4, 5 and 6, 7 and 8. Go ahead and read this article and summarize them as you go.